Good morning, everybody. Good morning. Am I audible?
Yes, ma'am.
Yes, ma'am. Good morning.
Yeah.
Yes, ma'am.
I hope your exam went on well. So we'll just continue with the topic today. Simply supported beam. Okay, just draw the diagram. All right. So draw the diagram, everyone. Please let me know once you're done. Can you also join your videos? Guys, are you done?
Yes, ma'am.
So let's try to calculate the reaction forces. So RA, you have to find out what is RA. And RB. Okay, I'll just write it here. All right, so we'll just do two problems on this and then we'll go ahead with overhanging beam. All right, so how do you calculate the reaction forces? So first is First is you need to calculate what is RA and RB. Okay, so we know that RA plus RB, because those are the only upward force, will be equal to 10 multiplied by 3 plus 5 multiplied by 2. Clear? Okay, so you will get, so this is RA plus RB. So this is all the vertical forces equal to summation of all the vertical forces equal to 0. So now let's take moment with respect to A is equal to 0. So first, first load is, let's take RB, we'll go from right to left. So RB multiplied by 7, okay, 3 plus 2 plus 2, and that is in this direction. So what is this direction? It's a anti-clockwise direction, so we are taking anti-clockwise as positive, okay, and clockwise as negative. So RB into 7. Next you have minus 5 into 2 load with respect to, so we have to take from the midpoint, okay, to A. So this is 1 meter. So you have 3 plus 2, 5 multiplied by 6. Got it? And then again another UDL is there. So 10 multiplied by 3 multiplied by 1.5. Okay, equal to 0. So you will get RB is equal to, do the calculations, everybody. Yes. Okay, equal to 15 kilonewton. All right, so if you substitute RB here, you will get RA is equal to 25. Please write it down. So this is the first step. Calculate the reaction forces at the supports. Let me know once you're done. Done, guys? Can I proceed? Yes or no?
Yes, ma'am.
Yeah. So I'm going to rub this. Step 1 is done. Now we will draw the shear force diagram. So we'll calculate the shear force. Okay, let's go ahead with step 2 now. All right, so let's do the calculations of how to calculate the shear force. Okay, at B. So you have a point load which is upwards at B. So you'll have to calculate just after B and then at B. So just after B, it's going to be 0. And at B, it's an upward force, so it is 15 kilonewton. Clear? And at point D, there is no point load, so no after and at. Okay, all of you know that point load, you have 2 points to draft in the shear force diagram. That's why we're doing after and at. Okay, so here at D, there is no point load. So what is the load here? You'll have 15 minus 5 into 2. Okay, I hope you guys are clear. All right, so 15, 5. Okay, now at C, it's going to be the same. Okay, 5 kilonewton. I hope it's clear. Then you have at point A. So point A has a point load. So after A and at A. So after A, it's going to be 15 minus 10. Okay, minus 30. 10 into 3. Clear? Okay. So it's going to be okay. So at A, it's going to be minus 25 plus 25. So it is 0 kilonewton. Clear? If you have any doubts, please let me know. We'll draw the shear force diagram now. Okay, so I'll use another color. Okay, this. Okay, so first you need to draw a line and trace the points. And then mark the points. Okay, so 0, and you'll have so 0 and then 15, So this is 15 kilonewton, and then we've got a 5 kilonewton here. So I'm going to name this D somewhere down and mark 5 somewhere here. Okay, so let's mark this also a little up. 15. This is 5. All right, and this starts with 0. Next, you have at C again, you've got again the same because there is no load between C and D. So you have again 5 kilonewton here. Okay, then at A, you've got minus 25 and then 0. So minus 25 will come somewhere here. And then 0. Okay, so for a shear force diagram we have learned last time is you need to just join the points. Okay, so you have, I'm joining these points. 1 second. Straight line. Okay, so if you notice here, you have a positive and a negative shear force diagram. Okay, so there is an intersection point here, okay, which is, say, take it as E. So we need to understand here, there are some little more calculations that we need to do. I will do it here. Okay, at point E, if you see the diagram, at point E, the shear force is equal to 0. Okay, so the shear force is equal to 0. So you need to calculate what is the shear force at, you need to calculate the distance. Okay, so I'm going to take E distance as X. Okay, so I'm going to take this distance as X. So we're going to find out what is X. Okay, so shear force at E is equal to 0. So now let's take only this part of the diagram. Okay, so you have so shear force at E is equal to 0. So how do you write this? You will have RA, which is a positive force, minus 10. So if you mark point E is going to be here. So we are considering only this part of the diagram alone. Okay, which is X. So if you take 10 multiplied by X equal to 0. Clear? So RA is 25. So you will have X equal to 25 by 10. So which is 2.5 meters. So this distance is nothing but 2.5 meters. Okay, so we learned in step 2. So this is step 2. So first step in this, step 2, you need to first calculate the SF shear force at every point. Okay, and once we do that, we draw the shear force diagram. And in this particular case, we have a point E. Okay, we get a point E where shear force is equal to 0. So what does that mean? That means whenever in the shear force diagram, shear force is equal to 0, at that same point in the bending moment diagram, the bending moment will be maximum at point E. Okay, please remember this. the bending moment will be maximum at point E. Okay, that means the shear force is 0 at point E. At the same time, the bending moment will be maximum at point E. Okay, let me know once you finish writing, and then we'll go ahead with bending moment diagram, because I'll have to rub this and then write. Done, guys? Can I rub it?
Yes, ma'am.
Okay. So now let's go ahead with bending moment diagram. So for the bending moment diagram, first of all, you'll have to calculate what is the bending moment at each point. So at B, then you have at D, at C, and at A. Okay, at B it's going to be 0 kilonewton meter. Okay, at D. Remember, we are always considering the right side of the diagram here. Now D. You have 15, so it's a anti-clockwise. So 15 multiplied by 2, and then you have minus 5 by 2 into 1. Okay, so what's the value? You will get 30 minus 10, 20. Okay, now at point C, it's going to be the same. No, it will change because the distance is different. 15 multiplied by 4 minus 5 into 2 into 2 plus 1, 3. Okay, that's what it's going to become. So this, if you calculate, you should get 30. Please let me know if I'm wrong, okay? It should be 30. And then we also have point E. What happened? Yeah. So at point E, so if this is 2.5, this will be 0.5. Correct? So I think I need more space to write this. So I'll take another color at point E. So it will be RB 15 multiplied by, how much is the distance here? 4.5 minus 5 into 2 multiplied by, you'll have 1 plus 2, 3.5. Okay, and then you've got 10 multiplied by 0.5. Wait a minute. 10 multiplied by 0.5 multiplied by point, doesn't fit. By 2. Okay, so what's the answer for this? Anybody got the answer? It should be 31.25 kilonewton meter. And at point A, it's going to be 0 because it's the support. So don't even calculate. You will get 0. Okay, now let's draft. Okay, so at point B, you have 0. At point D, it's 20. At point C, it's 30. At point E, it's 31. And again, A is 0. So 20, 30. This is 31. Okay. And how will you draw the diagram? So it's going to be a parabolic curve from A to C. Okay. And then a straight line because there's no load. And then again a parabolic curve. Okay. So this is your bend. Okay, if you have, can you see the screen now? Are you guys able to see the screen? Am I audible?
Yes,
Yeah,
yes,
you can see it. Okay.
yes, ma'am.
Let me know once you're done. Then I'll draw the next problem. You guys are done?
Yes, ma'am.
Okay, so now what I'll do is I will draw another problem. You guys can do it as homework. Okay. Again, it's a simple problem. Tomorrow we'll go ahead with overhanging. It will take some time for us to understand that. Okay, so this is your problem statement. Please solve it and come by tomorrow. Okay, let me take your attendance. Yeah. Karan, please answer your attendance. Karan, UL1. Alan,
Present, ma'am.
Subhashram,
Present, ma'am.
Richin, Richin,
Present, ma'am.
Tom,
Present, ma'am.
Present, ma'am.
Anthony, David,
Present, ma'am.
Calvin,
Present, ma'am.
Brian, Astor,
Still present, ma'am.
Jacob, Evans,
Been present, ma'am.
Jacob, Praveen,
Praveen present, ma'am.
Vishnu, Jerry, Prashant, Mukesh,
Present, ma'am.
Mukesh, Ashwin,
Present, ma'am.
Rohit,
Rohit present, ma'am.
Abhikash,
Abhikash present, ma'am.
Tarun,
Present.
Sam,
Tarun present, ma'am.
Sam present,
Sam,
ma'am.
Sriram,
Present, ma'am.
Arun, Siol,
Present, ma'am. Here,
Jason,
present, ma'am.
Jason,
Present, ma'am.
Tristan,
Present, ma'am.
Akash, Febin,
Present, ma'am.
Balakrishna, Mohammed,
Present, ma'am.
Mohammed,
Present, ma'am.
Balakrishna,
Present, ma'am.
okay, Alex,
Present, ma'am.
Sam,
Present, ma'am.
Partha, Ajay,
Present, ma'am.
Partha,
Present, ma'am.
Shai, Shai Kafrid, not present. Jeffrey, Deepak,
Present, ma'am.
Present, ma'am.
Sushil, Joel Verma,
Present, ma'am.
Richard,
Present, ma'am.
Gibson,
Present,
Mithun,
ma'am.
Gibson Sam,
Yes, ma'am. 47 present, ma'am.
who?
Ma'am, 47 Tirumala Mithun.
Okay, Gibson Sam,
Yes, ma'am.
Bharateja, Aditya.
Present, ma'am.
Absentees
Yes,
are
ma'am.
41, 36, 17, 15, 14, 11, 5, and UL1.
Ma'am, 5 present, ma'am.
5 is present.
Ma'am, 14 present, ma'am.
Okay.
Hello, ma'am. I came as newcomer.
Vigil.
Hello. Yeah, ma'am.
Did I take your number? Did I call out your number?
No, ma'am.
Your name is not. When did you join?
This is first class of you.
Okay, okay. All right. You can just check with Mohan Sundaram sir or your mentor and tell them your name is not there on the list to
Okay,
add it.
ma'am.
Okay. So
Hello.
the absent, yes.
Hello, ma'am. I'm new joined. My name is not came.
Oh, you're also newly joined.
Yeah,
Sridhar.
ma'am. Yeah, ma'am.
Yeah, same thing with what I told Vigil, no? You can also
Yes.
follow that.
Okay, ma'am.
Okay. So
Thank you.
UL 1, 11, 15, 17, 36, and 41 are absent. Can I save it? Yeah. Okay, since we have 5 more minutes, I just want to share the marks. Okay. That we have received for your internals. And it is here. Okay, let me share the screen. Yeah. Can you all see the screen? Is it visible, guys?
Yes, ma'am.
Yes, ma'am.
Yeah. The scores are average. What happened? You all can see your marks, hopefully. 42 has scored well, and 48. What happened to 41? You didn't attend the exam? 41 is absent today also, no? Okay, so 48 and 42. And then the next highest is 29. All right. Was it simple or easy? Was it easy or tough, the exam? How did you guys find it? Richard?
Yes, ma'am. It was
Ma'am,
easy.
my register number is not there, ma'am. My mark.
Calvin?
Mine is well.
Even
Calvin.
my number is not there, ma'am.
Oh, okay. I'll have to add your registration numbers. Wait, let's try that. Just a second. Let me try this and then let's see if your numbers come. Okay. Now let's see. Now check if your marks are there. I mean, your names are there. I hope you guys are able to see the screen, right?
Ma'am.
Yeah. Check.
Yes, ma'am.
It's come.
Yes, ma'am. It's there.
Okay. I think all the numbers have come now. Only one absentee. Rest everybody has written the exam. Good. Okay, so I'll upload these marks today in EduServe. All right, thank you guys, and please finish your assignment. I've given you one problem today. Do it in your notebooks itself. At the end of the unit, you have to submit it as an assignment.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Okay, so Pam over.